In today's video, we're going to look at section 7-2, dividing monomials. So, to divide two powers with the same base, we need to subtract the exponents. So before, when we multiplied two powers with the same base, we would add the exponents. So it's literally just the opposite. So if you have b to the 15th over b to the 7th, you just take b to the 15th minus 7 and get b to the 8th. So it is really that simple. So let's start. Simplify a to the 5th, b to the 8th, divided by a times b to the 3rd. So you just divide like parts. So I'm going to rewrite this. A to the 5th, b to the 8th, over a, b to the 3rd. So like parts. Since it's all multiplication, so a to the 5th over a to the 1st just becomes a to the 4th. And then the second part, b to the 8th divided by b to the 3rd, subtract 8 minus 3, you get b to the 5th. And that's your answer. And that's all there is to it. So when you divide powers with the same base, you just subtract. So, for the power of a quotient, to find the power of a quotient, find the power of the numerator and the power of the denominator. Okay? So, when you have a over b to the m power, you can, kind of like before when it was just a times b to the m power, you just kind of distribute that m. Same thing, you're going to distribute to the top and you're going to distribute to the bottom. Okay? So that m is just kind of getting distributed to everything on the top and everything on the bottom. That's what we're going to look to do. And sometimes you have to apply old properties. So we have 2p to the 2nd over 3 all to the 4th. So I'm going to take that 4, I'm going to rewrite this whole thing again, have more room to work. So 2p squared over 3. Alright, so to the 4th. There we go. So again, that 4 is just going to distribute to everything on the inside. So it becomes 2 to the 4th times p squared to the 4th all over 3 sorry, I had a watermark on my screen I had to get rid of, to the 4th. Okay, so then now we can apply old properties. This one will now multiply because it's power to a power, so we multiply those, so we get 2 to the 4th, which is 16. So we have 16 times p to the 8th over 3 to the 4th, which is 81. And there we go. Okay. So this is one of the best properties because any non-zero number raised to the 0 power is 1. So as long as it's not 0, if you go something to the 0 power, you will always get 1, no matter what it is, except 0. So I'm going to write that in there, not 0. Okay? Not 0. Anything to the 0 power is 1, not 0. And you can't take 0 to the 0 power. So simplify each expression. Assume that no denominator is equal to 0. So we have negative 3x to the 5th over y divided by 8xy to the 7th, all to the 0 power. So this whole thing is being raised to the 0 power. So we could simplify the inside and do x to the 5th minus over x and y over y to the 7th. But it doesn't matter because the whole thing is to the 0 power. So the answer is 1. No matter what. Next one. We have t to the 3rd, s to the 0 over t. So right away, we only have we have s to the 0. That's just 1. That goes to 1. And then the rest we can just go t to the 3rd divided by t. Well, 3 minus 1 is t squared, so it's just t. So it's 1 times t squared, or just t squared. So anything to the 0 power, that's a nice little thing you want to look for. The next one, the negative exponent property. So if you have a negative exponent, it flips what it's attached to. Okay, so for any non-zero number a and any integer n, a to the negative n becomes 1 over a to the n. Okay? So if you have 5 to the negative 2, that becomes 1 over 5 squared, or 1 over 25. And if you have a negative on the bottom, it flips to the top. Now, keep in mind, it still works with fractions too. It flips the fraction. It becomes a reciprocal. So if you have let's go 3 over 2 to the negative 2 power, that negative will flip the whole fraction inside. It becomes 2 to the third to the positive 2. So that negative will flip the fraction itself. Okay? So simplify each fraction. Assume that no denominator is equal to 0. So now we have b to the negative third and c times c squared over d to the negative fifth. Now there's nothing the same, so we can't really use any of our other properties. So that b to the negative third, that negative will drop the b down, and the d to the negative 5, that negative will bring d to the top. So we end up with c squared d to the fifth over b to the positive third. So when it moves it, that negative goes away. And there's nothing else we can combine, so we're done. Okay, let's look at another one. A couple more, actually. Negative 3a to the negative fourth, b to the seventh, over 21 a squared, b to the seventh, c to the negative fifth. So right away, we can see negative 3 over 21. Negative 3 over 21, we get negative 1 over 7. And then remember, anytime you subtract things, they go to the top. So we have a to the negative fourth over a to the second. So it's a to the negative 6, negative 4 minus 2. I'm going to extend my line here. And then we end up with b to the seventh over b to the seventh. Well, 7 minus 7 is 0, so we get b to the 0. Up to the 0, that's a good thing. And then c to the negative fifth, that is just by itself. Okay, so now let's apply all our properties. B to the 0, that just goes to 1, so it goes away. A to the negative 6, that's going to drop it. And c to the negative fifth is going to raise it up. So we end up with negative 1, and we have c to the negative, to the positive, that negative goes away, I got ahead of myself. C to the positive fifth over 7a to the positive sixth. Notice how the negative exponents didn't change positive or negative worth or value. So write the ratio of the area of the circle to the area of the square in simplest form. So we got to find the area of the circle first. So the area of a circle equals pi r squared, and area of a square equals s squared. So if we look close, the radius is right here. Well, we don't know what that is. It's r. Okay, well, how long is one of the sides now? How long is one of the sides? Well, if we take that radius and extend it, it makes one whole side. So it's actually 2r. So one whole side is 2r. So we have pi r squared over 2r squared. So we can do a little simplifying. Can't do anything to the top right now. Pi r squared. But we can take that square and distribute it. So 2 squared would be 4, and then we get r squared. Well, now we can do a little bit more simplifying. R squared over r squared, that just cancels itself out because 2 minus 2 is 0, and that's just 1. So we're left with pi over 4. Nothing else we can do. So the ratio of the area of the circle to the area of the square in simplest form would be pi over 4. All right.